Okay, so spheres. This is, you've learned this in pre-algebra and algebra, I believe. You've learned the volume, how to calculate the volume of a sphere. Have you learned that? You've learned that before? So if you had so this is a sphere, not a, that's a sphere. Okay, close enough. With a radius of r, So we're going to learn two equations today. First one is the volume. This is the volume of a sphere. Okay. And the surface area of a sphere is that. These are the two equations that you need to learn today. Volume is 4/3 pi r cubed. The surface area is 4 pi r squared. Okay. Example number 1, find each measurement given your answer in terms. So in example number 1, we are told that r is equal to 9, and they want us to find the volume. So the volume is 4/3 pi r cubed, right? Pi r cubed. So it's going to be 4399993, 81 times 12. So it's going to be 972 pi. 972 pi. Okay. B. Find each measurement, give your answer in terms of pi. B, the diameter of a sphere in the volume of, so this is the other way around, right? They're giving you the volume. They're telling you the volume is this. So obviously the radius is going to be this, right? Okay. So, but if we had to do this backwards, okay, if we didn't do this one, and they told us that it was 972, you would solve it by saying that the volume here is 972 pi, and this is equal to 4/3 pi r cubed, right? So first thing you would do is get rid of the pi's. This is on both sides. You divide it by pi. And then you would have r cubed is equal to 972 times 3 divided by 4, right? And then you would work it out, and you would get 729 is equal to r cubed. R would be equal to 9. Obviously, 9 cubed is 729. So, and you want to know the diameter. So the diameter is going to be twice this. So the diameter would be 18. C, the volume of a hemisphere. A hemisphere is nothing more than half of a sphere. So half of a sphere. So the volume of the half of the sphere, you want to know if the r is equal to 4. So they're giving you r is equal to 4, so the volume of a full sphere would have been this, right? But then they're telling us it's a hemisphere, so if you go like that, right? Okay, you'd have to do half of that. 4 cubed is, anybody? 16 times 4, what is it? 64. 64 times 2 is 128 divided by 3 pi. That would be your answer. Okay, so that's that. Let's go ahead and do example number 2. Giant squid need large eyes to see their prey in low light. Okay. Does anybody know how they catch squid? Catch squid? And they actually go fish for squid. They always go at night. They don't do it in daytime. They go at night. And they hang a light over the boat. And they get attracted to that light. The eyeball of a giant squid is approximately a sphere with a diameter of 25 centimeters, which is bigger than a soccer ball. Human eyeball is approximately a sphere with a diameter of 2.5 centimeters. How many times as great is the volume of the giant squid eyeball as the volume of the human eyeball? Okay. So the volume of the squid eyeball is R cubed. And what is R for the giant squid? 25. That's the diameter, correct? So the radius would be this, right? The volume of a human eyeball is what? 2.5 divided by 2, right? 2.5 divided by 2. Okay, so we're trying to find the ratio here, right? Isn't that what we're trying to find? How many times, right? So obviously this and this goes away, right? 25, oops. 25 cubed over 2 cubed, 2.5 cubed over 2 cubed. These are the same, they go away. So what do I have? I have 2.25 cubed over 2.5 cubed, which is the same as cube. What is 25 divided by 2.5? Spit it out. 10, right? It's 10, right? $1,000 times, right? Okay, so there we go. That's that. Flip the page. Go to example number 3. Now we're talking about the surface area. Okay, remember what's the surface area? And so the surface area, our equation was 4 pi r squared. Okay. The surface area was 4 pi r squared. Example number 3. A, find the surface area of a sphere of a diameter that is 10 feet. So it's going to be 4 pi, diameter was 10 feet, so the radius is 5. 4 times 25. So that was A. B, find the volume of a sphere that with a surface area of 144 pi. So from the 144 pi, I have to find out what the radius is, right? This was the surface area, and this is 4 pi r squared. Right? So I have to find out the radius, because in order to find out the volume, I need the radius, right? So the pi's cancel out, divided by 4, goes away. 36. Right. R would be 6. So the volume is correct. Okay. So this would be 72, 288 pounds. Is that correct? 288. Okay, so C. The surface area of a sphere with a great circle that has an area of 4 pi. Okay, I don't get this. Oh, area, okay. So the great circle is, when I cut it in half, the largest circle that a sphere can have. Okay, that's why it's called the great circle. So the area here is what? What is the area given to us? It's 4 pi. So 4 pi, and that's the same as pi r squared, correct? Right, because r here, and it's going to be the area here. Pi goes away, r is equal to 2. And I want to know what the surface area, do you want to know what the surface area was? Surface area. So the surface area is 4 pi r squared. 4 times 4 is 16. 16 pi. Okay, number 4. Explore the effects of changing dimensions. The radius of a sphere is tripled. Describe the effect on the volume. Okay, so our original volume was this. This is our original volume. Our new volume, after we triple the radius, is going to be that. Does that make sense? Like triple the radius, right? That's what I did. Guy goes away. Pi 3 cubed. Pi r cubed. Pi's cancel out. These cancel out. So when you triple the radius, the volume gets multiplied by 27. Okay, that makes sense? Okay, so where are we at? Example number 5, last but not least. Number 5, finding the surface areas of the volumes and volumes of the composite figure. Ooh. They're going to actually have you do the surface area of a cone. Okay. All right. So let's do the easy part first. Let's do the volume. How am I going to do the volume there of this ice cream cone looking thing with the actual ice cream on top, not just the cone? How am I going to find the volume? I just put it in 2 parts, right? I can't do them together, right? So it's going to be a hemisphere, right? And we're going to add to that the cone, right? So the volume of the hemisphere, volume of that hemisphere is going to be, what's my radius here of the hemisphere? 7. So this will be a full sphere, but we're dealing with a hemisphere here, right? So it's 1/2 of that. Okay, now let's see if we can remember the cone, the volume of a cone here. The volume of that cone, so this was the hemisphere, this is the cone. Volume of the cone is the base area times the height, and then what? I have to divide that by, what's the magic number? 3. So, what's my base area there? Pi r squared, right? R was 7. The same 7 there. What's the height? 25, is it?
Yeah.
And then we're going to divide that by 3, right? So if you add these 2 together, you would get the total volume. I guess we should do this. 2, 7 times 7 times 7 is 28, 34. 2 times 3, 43. Pi divided by 3. 686 pi divided by 3. Over here we get 49 times 25. 4, 8, 5, 2, 1, 2, 1, 2, 2, 5 pi divided by 3. If I add those two together, I get what? 3 over 686 pi plus 125 pi. 1, 1, 9, 1, 3 pi. Yes?
For the cone, wouldn't the height, would you use the Pythagorean theorem to find it? So it would be 25.
Oh, okay. So I thought that the dotted line was 25. Okay, so it's not. So then how would we do it? We would do the good catch there. Oh, this would be the height, right? Or the height. Yeah, this would be the height. Okay. So what do you get? 625, 49, 687, 65. What's the square root of 576? Is that a magic number? It is, 24. 24. So it's not 25, it's 24. Dang. 8. Right? So it's 49 times 8. So it'd be, oh, there's no 8. 392 pi. You would add these two together. Okay? Yeah. Good catch, thank you. Okay, so that's that. Oh, we're just doing the volume. It says to find the surface area too. How did they find the surface area of the cone?
In step 1.
Yeah, it says the surface area of the composite figure is the sum of the surface area of the hemisphere and the lateral area. So,
Oh, okay. So pi RL. Pi RL, where L is the 25. Okay, there you go. So everybody see that equation there? That's the one that I really wanted to point out. So the cone, okay, the surface area of the cone, okay, is, so here's the cone, right? We'll just look at the cone here. This is 25. This here is 7. Okay, so it's pi R L. So we haven't talked about. Okay, something you probably learned back in algebra 1 or whatever and not paid much attention. Okay, this is how you calculate the surface area of the cone. Not the top part, right? Because the top part is not exposed, because on the top you're going to have the hemisphere on top, correct? So this is just the side area when I cut it open and I flop it open, right? Because it's going to look like, it's going to look like this, right? Right? If I cut this guy right here and I flop it open, it's going to look like that. Okay. So that's how you calculate this area. Okay. This hopefully will not be on the test. Okay, it's not something I expect you guys to know. Okay, this is more of a introduction to the concept here. Okay. All right, we're done. Done.